Yeah, okay, so
Two part two.
2 part 2.
Yeah, that was the one you showed us yesterday.
The angles.
Yeah,
Okay.
It false.
Okay.
Question 1 part. Yeah, question 1 part.
You want to see 1 part 2 and 2 part 2, is it?
No, it's the question 1 part 2.
Oh, that's what we need to do now, is it? Is
the
part
one with the choy.
Is part 1 not related to part 2? Do I need to do part 1?
Yeah, sorry, question 1.
It's related, but I mean it's meters. So calculate the acceleration, and they give you meters.
Oh, so I kind of need to do that for the second part, yeah. So what's the setup? You have a trolley going down a hill, basically, is it?
Yeah.
Inclined slope.
And they give you.
Now, yeah, oh, and that's where they give you info, isn't it? So
they give you the meters that
it travels, yeah.
Travels and the seconds.
Yeah, so what is that info?
Yeah, just
Displacement 3.6.
Hang on, let me just, before I do that, let me do this properly. Okay. Right, sorry, and there's the trolley going downhill. Okay, the U, 0, V we don't know, A we don't know, T we do know. What is it?
1.56.
Okay, seconds, and S.
3.6.
And they ask you for the A. And I'm sure that's easy peasy, right?
Yeah.
So what do you get for A?
2.96.
Okay. Now, let's draw the forces. There are exactly 2 forces acting on this trolley. The weight, which we don't really know, right? Because we don't know the M. So we just have to say mg. And what's the other force here? Reaction here. Yeah?
Is it?
Reaction is always perpendicular to the surface
Okay.
that it's resting on. Why it's sometimes called normal reaction. Yeah? Is that okay? Yeah. Now, and this angle here is
What they want.
theta, which is what they want. So, we're all right with the first part. Let's go to the second part here. Watch this. If I just flick my diagram, so it's like this, pretending now that we're the physicist and we're standing so that the ground is horizontal. From this point of view, it looks like the ore is still perpendicular to me, but the mg looks like it's acting at an angle. And really, the mg, now we can think of it as having 2 components. Now, if that's theta, you can do a little bit of geometry, and this will, you discover, will be theta as well, if you do your triangles. Which makes this one here mg cos theta, because it touches the theta. And this one here is mg sine theta. So you know that ore must equal mg cos theta. Yeah? And the mg sine theta, that's the force making it move down the plane, accelerating it down the plane, which according to Newton is ma. Yeah? So that m can cancel that, and you end up getting sine theta equals a over g. So that means theta is sine inverse a, which is 2.56, was it? What? What's the a that gave you? Or we worked out?
2.96.
2.96 over 9.81.
17.6.
Now, is that the answer? Is that fine? Is okay or not? I'm not sure what you're thinking.
Can you just show us the geometry, how theta?
Yeah, sure, absolutely.
Because
It's not clear, yeah. So, I'll just draw it a little bit simpler, okay? I'm going to draw it, there's the plane, okay? There's the ground, there's theta, right? And then let's say here's the weight. Okay? And the weight has a component this way. I'll just call that WX. And it has a well, actually, I don't want to call it X. No, I will call it X, sorry. WX, and this one here, we'll just call this component WY. Is that okay so far? Yeah? So, if I was to make a big triangle here of 90 degrees, who's calling me? Oh, I'm too popular. Right. That's theta. That's 90. So what would this angle here be? 90 minus theta. Now what is this whole angle here? 90. So what would this angle be? That'd be 90 minus theta, which is also known as theta. So if that's theta, then this angle here is theta, the angle belonging to the direction perpendicular to the surface in the opposite of the reaction. Wow, I'm seeing lots of confused faces. I'm not confused? These are faces of understanding? Yeah, okay. Yes? Oh, no, that looks confused. Okay, alright, no, it's okay. Are we okay with this? Are we sure?
Yes.
Well, you can always watch the video again if you need to see it a second time. What's the next example we needed to do? I think you said there were two, weren't there?
Yeah, the second question was really straightforward.
No, but what do you need to see or not? No, we're finished with. Okay, great. So we'll continue then. All right.